Okay, hello class, weekly update 5. Let's jump right into it, your activities. So some really good work here, and as usual, I'll share the screen. Go to the samples and examples section. Okay, so we are in module 3, samples and examples, week 1. Okay, so lots of names. Rochelle, Sharidra, Noah, Chris all did really nice job on the cloth over junk. I liked Chris's, he used a mask, seemed appropriate during COVID to be the cloth. And then I want to point out a few that we'll look at. Sharika did a really nice job with the boundary to make the different cases for the extrema, like the global extrema occurs on a boundary when there were ties. Before we get to some of the examples, just some other comments. So Lauren was one of the few people who did the watercolor man, so I put hers in there. And thank you to Calvin, Wade, and Madeline for noticing an answer key typo on the hand play one. So they noticed that my answers had like 0 global max, but that I had the numbers flip-flopped. But right, these are all, I'm sorry, local max, right? So those are all local max, so 4 of those, and then 3 saddle points in between the knuckles. So I think I'd flip-flop that 0 and 4. So bonus for folks that do that. So bonus point for Calvin, Wade, and Madeline. Let's see. Okay, then let's go to Grace's. This is for the eyeballing local extrema. This was the first activity. And you're just looking at the picture and trying to see if you can just know your key terms. And what I liked about Grace is always really nice display. But so you have the equation here. So she went ahead and actually tested it with the d-test. So she did it here on the surface. And then she went ahead and showed the work for the d-test, which you learned later. What she did, she knew that. So it was a good way to go ahead and find that hidden one. And yeah, usual work here again. Local maxes, saddle points in purple. And nice job on the hand. All right, let's go back. Next one, let's go to Haley's. So this was the reason I put it. I want to highlight Haley's activities. Yeah. This one she did for the cloth over the junk activity. Oh, right. So this one she says like, oh yeah, sorry, I'm not, sorry. Eyeballing the local extrema activity. So, you know, again, finding that unlabeled one, she was actually saying, hey, I have the equation, let me put it into a tech tool. She puts it in a tech tool, rotates it, and then it's easier to find that hidden saddle point. So really nice job. Always know that you can resort to those. This is what I'm talking about here. I mixed up on the answer key down here, right? That should be 0, 4, 3, but most y'all got that. Next one, let's go to James. Okay. This was, okay. So I liked his different cases. Oh, same thing as Haley. So he went in to check that tech tool, found the saddle point, right? It was hard to see unless you rotated it. Really nice explanation, local max. Yeah, oh, this was neat, right? So he had this plateau, right? So these are all local max right here. We don't have good techniques in calculus to find these, and these are actually difficult even if you go to graduate school to find all points in this. Maybe you could find somewhere around the boundary, maybe you could find what are called these corner points, and I'm actually teaching my graduate class 551 this semester, and we can do some of these. So this was a really interesting case to me. Here it is with the boundary. And then all of these, I'm sorry, are all of those in that case are local, which over this region, they all end up being global. Yeah, and again, he's changing the boundary sign. So really nice work and explanation. Then on this one, he moves the boundary so that it is the global max occurs in the boundary. So one of the main takeaways from this activity was that there are a couple places you look for extrema. You look at CPs and boundary. Oh yeah, here's one with the top. Okay, one more to look at for this activity. Meta activities. Okay, and as usual, I like the explanations and like where she's stuck or not understanding something. She talked about how some of these saddle points were hard to find. She labels like, this might be when you want a min in one direction, a max in the other. Yeah, it looks like it is hard to identify, but that's where the calculus comes in. Okay, oh yeah, this one here, she has a water bottle laid under there that makes what I think she calls one of these, like, oh yeah, when she went into her professional level digital art skills. This one modify the region. She says, yes, okay. This water bottle, which she's saying kind of could create what she's calling a critical line, right? This is like a ridge, and everything along there is an extrema. And how do we find those? And those are harder again. If that's on a boundary, again, sometimes we're good at getting like the entire set of all the points, so we can actually know that there's infinitely many between here and here, and we can get that. But the way she has it set up, it's not on the boundary, right? It would look like it needs to be a CP, but CPs are one point, right? So how we do this, and that's beyond the scope of the class. So I just thought it was super cool to think about the theory. Example here, we're good at finding things like that, and like not getting all possible. We might get a few here. We'll see for certain types of problems, but that was a really interesting case. Okay, let's move on to the calculations. So lots of folks have put in here, David, Noah, Phoebe. I really liked their layout and that they were so step-by-step, like Phoebe's like step 1 to step 2, that so on. Let's go to take a look at James. Where's James? Thought I put James, I'll have to add it. James had calculations where he made a nice table for the d-test. So that's once you've done all the work, you now have to check like say 4 points that are critical points. I need to check them in a nice table, did the f sub x, f sub y, and then went through. That was really clear. Let's see. Let's take a look at gracing. Grace calculations. Okay, super well organized here, very clear what's happening for each of the problems that she did, how she breaks out to get the critical points, tests each one, nice little boxes, runs the d-test. Nice, compact, and clear. Okay, so take a look at that. And then another one that I thought was really clear and organized is grants. Okay, again, it's really clear what he's doing here. I got my partial, I got my second partial. Hey, I'm going to go find critical points. Listen the critical points, putting each one of those, showing the formula there, each case, the negatives, and check them out because sometimes you did number 1, but say Grant did number 2 here, and you didn't do that one, but it's nice to have these when you're studying, and really clear work all the way through that. So nice job. Thank you, Grant. That's service to your classmates. And I think did many of the problems are more than was required. That's also nice. One more, let's check. 9 calculations. And so just a couple comments here that I wanted to point out. So again, she talks about this and where maybe there are errors. Like she says, I did to get the CPs, I was forming all possible XY combinations, and then some of those don't actually satisfy the f of x equals 0 and x of y equals 0. Like you can try all possible combinations, make a list of all what you think are possible CPs, and then you're going to go in and cross out some of those because they don't actually, when you plug them back in here, say you got a CP you're checking 1, 1. Well, I have to say, does f sub x 1, 1 plug in and give me 0? No, then it's not a CP. It has to happen. F sub y at 1, 1 would also give me 0, right? So it was really nice to see her approach there, her thought process, and then the usual work. Okay, and then I think there's a really nice other, oh yes, this one. She's saying, I got a couple more CPs than were listed. And does that mean saddle points do not count as extrema? Yes, that's true. So let's just make sure our vocabulary, extrema means extreme in one direction or the other. So you're either a max or min. So if a CP, CPs that are extrema are local max or local min or global max or global min. But saddle points are neither local max, local min, global max. They're not extreme at all. Saddle points look like they might be in one direction and the other direction, but it's sort of conflicting information. It looks like a max here, it looks like a min there. Saddle points are their own definition. So critical points that are saddle points are not extreme. That's the moral there. So you're right on that. Yes, is the answer. Oh, okay, so the other comment, I really like that she chose this one. I don't know that very few of you did this problem either. Number 4 she chose. And she's saying like, look, I went and got CPs and those are the correct CPs. She did all the right work. And then she's saying I did a D test on 0, 0 and I get 0. And that was one of the cases that could happen. Doesn't happen often, but it could. And when it does, it says the test is inconclusive. What does that mean? That doesn't mean that that CP is nothing. It means we can't use the test to determine what it is. And so what Marilyn did, she went and actually, I think she graphs this. She said, yes, I know from the graph, this has to be a saddle point. And I know it from the contour map. I know it from the R3 graph. You're right. So that's the, take that inclusivity and make it a conclusive. You made a conclusion that is correct. You just couldn't make that conclusion with the D test. It's possible. And that we had that back in Calc 1 when we did the second derivative test. Remember, if the second derivative at a CP equals 0, that test is inconclusive. You have to do something else. Often you went back to the first derivative test. So this is the same thing. When you get that, you have to go to other methods. In this case, it was some visualization of the contour map. Okay, so really nice job there. Let's conclude last few things. That you had your discussions, which was verifying a textuals. So let me just summarize some of the things folks said. I guess we don't need to share. No, okay. So you could, some common trends were use another tool, double check your work by hand. This is a slightly different one. Work a similar, easier problem has a known answer. So Wade and Haley talked about this, and Haley mentioned maybe looking for syntax errors. And then several people mentioned falling back on logic. Okay, so falling back on logic would be things like, well, I know by the partials, the function should be increasing or decreasing here. I know I shouldn't have negative gradients for this particular function. I might know the domain and range. So those were people like Noah, Chris, Kyla, Aaron, and Gavin. And like, what else do you know about the function that can help you check, especially if you're looking for, say, just a visualization of the surface. A really nice summary. I liked what Calvin, James, and Jake all had to say. Jake talks about how at every step of his work, when he's doing the computations by hand, he's always asking himself, like, why this step, why this step, why this step. And that's great. And then many people came back to this. Well, I'd check it by hand, but I need to rephrase this question because it wasn't quite clear. And I think James made a comment to this effect that I'm wondering, how do you verify for a problem where you can't check that? Like the reason you're using this tech tool is the problem is so hard, it cannot be done by hand. Like some of these CP problems, we're finding that we have an f sub x equals 0 equation and an f sub y equals 0 equation where it's so difficult, you would need to take a graduate class or numerical methods to find that. You can't do anything by hand on those. And if that's the case, then you're going to go use a tech tool. And the tech tool is actually doing those numerical methods behind the scenes, things that you haven't learned yet. Or if you're a math major, you might take numerical methods class or go on to graduate school. So you cannot do it by hand. I guess that was the point. How do you verify a tech tool's answer when your work can't be done by hand? What are some things you do? And so I think there's only a few folks that talked about like, well, maybe I have to actually work a similar but easier problem that I can do by hand to make sure that I'm doing the syntax, putting in the syntax of this tool correctly. So once I've verified that, that gives me a little bit of hunch. Again, I can't be certain, but then you can fall back on these logic things. You have a reasonable hunch, like I shouldn't be getting a negative number here, but I am, so maybe I made an error. Okay, a few last comments, logistical things. So this next week, you'll notice a few things I want to point out. So there's just a couple of you that keep mention like, hey, finding CPs is kind of tough for me, solving those equations. So you'll notice there is another video in week 2, CP practice or CP review or something like that. So check those out if you're one of the folks that's having trouble with those. Some CPs you can do by hand, some of them you can't, but some of those equations are a system of nonlinear equations, which is tough, and you're welcome to use a calculator. But knowing when it's capable of doing by hand and then at which point it's too difficult, that can be tough. So check out the CP review and give me some feedback. If I have to, I'll make another one. We'll try and make another 2 or 3. Okay, last thing is that there is a practice midterm. We don't have a midterm in this class. Remember your challenge problems, put in so much work as a group and effort. You're doing a really nice job. Those basically count the weight of exams as we go throughout. All of this is meant to prep you for a cumulative final exam. And so some semester students have been a little worried, like, hey, where do I stand? Like, I want to be ready for that sort of traditional final exam. Let's just see what a midterm. So I'm not grading this. This is just optional. I suggest everyone should print it, take a look at it, get ready, and you'll just see that how good you've gotten from this method, working with your groups and doing these activities and calculation sections, that you'll be ready. And that should be, these are, I actually took this to make this practice midterm, took it from a couple of my colleagues in their traditional classes, and you should look at this and say, oh, no problem, I got it, right? So these are traditional calculation questions that we can take a look, and then notice that there are solutions posted work from a former student did a really nice job. We went through those step by step. So if you have time, take a look at the practice midterm. If you have time, do some of those. If you have time, take a look at the solutions that are posted. All right, and keep emailing with questions. Me and Chloe are here to help you, and hope you're having fun. This should be another fun week because you're doing some really cool applications in week 2 of this module. All right, have fun. We'll see you next time.